Hey guys, welcome to the next video on Python tutorial for beginners. In this video, I'm going to show you how to use nested functions and closures in Python. So let's get started. So we will start with the nested functions. So in Python, we can define the nested function. That means we can define a function inside a function. So let me give you this example. And in this example, this function, which is an outer function, takes some text or message as the argument, and I have defined one more function inside the outer function and I named it as inner function, which prints the value of the text which we have passed in the outer function, and we are just calling the inner function in the outer function scope. So this function is declared locally inside the outer function, and we are just calling this inner function inside this outer function. Now, in other words, we can also say that this outer function is an enclosing function and this inner function is the local function of this outer function. And now when I call this outer function and let me run the code, it's going to just print the value which we have passed as an argument. So we have just passed this text argument, which is once again passed to print statement of inner function, and because we are calling this inner function inside this enclosing function, it prints the value using this statement. So when you declare one function inside the another function, it's called the nesting of functions. Let me give you one more example of the nested function, and I have defined this pop function, which is our outer function or enclosing function. And here I have defined a function called getLastItem, which is our inner function or the local function to the pop function. Now this pop function takes a list as an argument, and we have defined a local function inside this pop function. And what this local function getLastItem does is, whenever you pass a list as an argument to this local function, it's going to find out the last element of the list and return the last value of this list. So here, this is the last index of the list, and then it's going to return the last item of the list which is passed as an argument. Now you may already know that you can call a function called remove on your lists, which is used to remove some item from the list. So I'm just calling remove function on the list, and as an argument of the list, I'm passing the function which finds out the last element of the list. So this is going to give us the last element of the list, and this last element will be removed from the list. And at last, I'm simply returning the list which is passed as an argument to the pop function. So let's say this is the list on which we are working on, which have 5 elements, and we are calling pop function on this list again and again 3 times. So let me run the code and let's see what happens. So you can see when first pop is called, it's going to remove the last element, which is 6, from the list. And then whenever the second pop is called, it's going to remove the 4. And whenever the third pop method is called, it's going to remove the 3, and so on. So this is how you can use nested functions in Python. Now let's talk about the closures. So I'm going to use the same nested function example which I have shown you earlier. So this is the nested function. Now in order to convert this nested function into a closure, what we need to do here is we need to return the inner function without the parentheses. So the thing to note here is we don't need to return this inner function with the parentheses. We need to return this inner function without any parentheses. And this is the simplest example of the closure. So what is a closure? So a closure is a function whose return value depends on the value of one or more variable which are declared outside the function. So in this example, this text variable is declared outside the inner function, and the value of this inner function depends on this text variable which is declared outside this inner function, and that makes it a closure. And closure have a special property that this closure function object remembers the value in the enclosing scope even if they are not present in the memory. So I will explain you that, but let me just show you how to use this outer function which now uses the closure. So I'm going to declare a variable a, which means because this outer function is returning the inner function, that means a contains now the inner function. So we can use this a as the function. So in order to use this a as the function, we can just call this a using the parenthesis, because this function doesn't take any argument, so we are not passing any argument here, but we will just call it as a function because this outer function is just returning the inner function. So let's run the code and let's see what happens when we run this code. So you can see it prints hello, which is printed using this print statement whenever we call this a function. So if I just call this a function without the print method also, it's going to print the hello, because here we are just using the print to print the text which is passed using the outer function. Now, as I said, closure is a function object that remembers the value in the enclosing scope even if they are not present in the memory. So our enclosing scope is the outer function. So even if we delete the outer function after declaring this statement, and if the a contains this inner function, and now let's say I'm going to just delete the outer function. So this statement is going to delete the outer function, and let me call this outer function once again after the deletion of this function. That means it's going to throw us an error which will say that this function is already deleted, so we cannot call this function. And now let's see the magic of the closure. So even if we deleted the outer function and we cannot call the outer function, but before deleting we have created a variable which contains the value of inner function, and now I'm just calling the inner function with these parentheses, and let's see what happens. So I'm going to just run this code and it's going to print hello even after we have deleted the outer function. So this means that this variable a is storing some kind of state of inner function even if the outer function is deleted, and that is the magic of the closures. So a closure function is able to remember the values which are declared outside the function also. So this is our closure function, and it's able to remember the value which are declared, which is text outside the function. And that's the beauty of closures. Now let me give you one more example of the closure so we will be able to understand it in a better way. So here I have defined a function called nth power, and I pass one argument here which is an exponent. And inside this nth power function I have defined a local function which also takes one argument, and then what it returns is the power of whatever argument we pass here, and this exponent is coming from the outer scope which is as an argument of the outer function which is nth power. So base is coming from the inner local function and the exponent is coming from the outer scope, and we are just returning this power of which is a local function without any parenthesis once again. So this is very important, you return the function without the parenthesis. Now I can declare some variable. First of all, I'm going to declare a variable called square, and then we will call this nth power function and we will just pass the value 2. So now this exponent becomes 2 here, which is also passed to the inner function or the local function. So here the value of 2 is saved. That means whenever we call the square function, it's going to give us the square of whatever number we are going to pass as an argument to this square. So let's try it once and let's see what happens. So I'm going to just print and then call this square function, which takes an argument, and I'm going to first of all find out the square of 2, and I'm going to run this program, and you can see it's going to give us the square of this 2, because now this square function is going to give us the square of the number which we will pass as an argument here. So this 2 is passed to the inner function, because this nth power gives us the inner function, because it returns the inner function. So now this 2 which we are passing in the square is passed as the base of this inner function, and that's why we are getting the square of the number which we pass here. So let's find out the square of some more numbers. So I'm going to just pass 3, 4 and 5 here, and I'm going to run the code once again, and you will see that it's going to give us the square of 2, 3, 4 and 5. So once again we have seen that the closure function is remembering the value which is declared outside the scope, which is exponent. Now whenever I use this function once again, so let me declare one more variable, and this time I want to declare a cube here, and once again I'm going to use the nth power to find out the cube of numbers. So now this 3 is passed as an exponent here, and this exponent is going to be passed inside the inner function. So exponent value is 3 here. That's why we are going to get the cube of the number which we are passing as the base argument of this inner function. So now this is the inner function, and we can once again call the print to call the cube method. This should be cube, not cure. So cube, and then we can find out the cube of 2, and let's find out the cube of 3, 4 and 5 also. So let's run the code once again, and now you will see here the cube of the numbers are printed, whatever numbers we are passing as an argument of this cube function. So in a way, this cube or this square variable is holding the status of the inner function, and that's something we have also seen in the case of classes. The classes are able to remember the state of the variables and the methods which are declared inside the classes. So closures are sometimes used in place of the classes which only have usually one method inside them, because this one method we can already define in the closure also, and it's able to remember the state. So closures can be used in place of the classes which have fewer method, generally one method inside them. The closures are also used heavily in the case of decorators in Python. So decorators we are going to learn in the next video, and I'm going to show you why decorator use closures and how to use closures with the decorators. And the third advantage of closures are they are sometimes more efficient than the normal functions. So the closures are sometimes also used for the code efficiency and the faster working of code. So this is how you can use closures in Python. I hope you've enjoyed this video, and I will see you in the next video.